and welcome to our first revision lesson on projectile motion. I have written out the notes that I think we'll need and a few practice questions on here. I've done a little reminder of equations for motion. I know you've done this a million times, so realistically I'm just reminding myself. So forgive me that, basically. But yes, here we go. I would say the best form of revision for projectile motion, as we know, is just questions. So very much our 3 revision lessons that we're doing this week on projectiles will be very question based. Hey, let's go. So first thing is just a reminder of the letters of SUVAT. Apologies that they've capitalised in there because they should be small, but hey ho. S displacement, U initial velocity, V final velocity, A acceleration, T time. I know you know this. Then I've written out our equations. V is U plus AT, S is UT plus half AT squared, S is half U plus V divided by T. Oh, sorry, half U plus VT. V squared is U squared plus 2AS, and S is VT minus half AT squared. Sorry, my cat's on my lap, she's moving around. Let's do a practice question, which I'm sure you could do in your sleep. If you want to pause the video, do your own one, and then check with my answer, that'll work. So a car is travelling at 28 metres per second. Where are we? Why is this not working here? Does that work? Can't tell if it's just not working because my pen is not working or whether it's just the way it's going. Oh, I'll charge it. Okay, right. A car is travelling at 28 metres per second. The driver applies the brakes. The car skids for 30 metres before stopping. Calculate the magnitude of the deceleration of the car. Right, hopefully my pen is now charged. Let's try this. So, right, clearly no, it was just... Come on, I want to type here. No, fine. I thought it was going to be really easy then. U is 28 metres per second. S is 30. V is 0. A is what we're trying to work out, question mark. Which equation links them all? B squared U squared plus 2AS. A, how am I going to do this? How much type? What a nightmare. What a nightmare. Come on. No, this is not working. Okay, how? I'll do it down here. That works, right. A is V squared minus U squared 2S. That's 0 squared minus 28 squared over 2 times 30 is 28 squared divided by 60. Double with my calculator. 13. And it's obviously deceleration 13.6 metres per second squared. Easy peasy lemon squeezy. Okay, so projectiles. I thought the easiest way of doing this was to write out the key facts, knowing that you obviously have the background information already, so hopefully these make sense when I read them through. Vertical velocity changes due to G. Now that could be that it's accelerating if it's going downwards, or obviously decelerating if you've got something that's being fired up, or even decelerating and then accelerating as it reaches the top of the turn and then back. Horizontal velocity stays constant. It is not affected by G, so A for horizontal velocity is 0. Time is the same for both horizontal and vertical motion. Vertical displacement generally is the height, and it is different to horizontal displacement. I know you know these things, I'm just saying them again. Use trigonometry to combine component velocities to find the resultant velocity, and vice versa. So I've just put a picture of the summary questions here. Thought that might be the easiest thing. How do I get rid of this drawing? Just get rid of all of this. Oh god, I'll be here for hours. Okay, right. I think that's got rid of everything. Yeah, just thought it would be easier if I answered them on here, really, and could talk you through them. So, question number 1. A ball is kicked in the air. Figure 8 shows the velocity components of the ball at a particular instant. Calculate the velocity V of the ball. So you're going to put your 2 components together to work out the velocity. Now, just a quick reminder that you will need to work out both the magnitude and direction, so it will need an angle. So the magnitude is nice and easy. You can use Pythagoras there. So what was that? 9 and 7. So A squared equals B squared plus C squared equals 9 squared plus 7 squared. So that 81 plus 49 is 90, 130. Square root of 130 is 11.4. Nope, sorry. So the square root of 130 is 11.4 meters per second, nice and easy. Next bit, you need your angle, so let's draw it out as a triangle. Where were we? 9 down to 7 across. V, which is 11.4, and you can use any of your SOHCAHTOA. So, full confession, I always write it out. I find it easier to remember. So, should we go? Do you know what? Let's use 9 and 7 because it's not rounded up, so it'll be our most accurate. So let's use tan. So tan theta equals opposite over adjacent equals 7 over 9. Tan minus 1 of that. What are we coming out with? 37.9 degrees. So that is 37.9. Bish bash bosh. And you should probably say to the vertical because that's what we're working out. Lovely. Right, so that's question number 1. Question 2a. A cannonball is fired horizontally from a cliff 29 metres above the sea. The initial horizontal velocity is 320 metres per second. Calculate A, the time of flight. Okay. Right, 2. Let's just write down what we know. So S vertical was, what was it? 29 metres. A vertical, obviously, is 9.81. U vertical is 0. T is what we're going to work out. So S is ut plus half at squared, would be quite a nice one. It's meant to be t squared, sorry, I don't know what's going on there. This is 0 because u is 0, so S is half at squared. T is the square root of 2s over a. It's the square root of 2 times 29 over 9.81. Put that in the calculator. I make that 2.43 seconds. So t equals 2.43 seconds. And remember, t is consistent for both horizontal and vertical motion. So part B, what are we doing? The horizontal distance it travels. Okay, the horizontal velocity is 220. So let's again write out what we know. S horizontal, we don't know. U horizontal and V, 320. A is 0. T is 2.43. So we may as well use the same equation. S is ut plus half at squared. A is 0, so that bit's out. S is ut is 320 times 2.43. Put that into my calculator. 778.1 meters. Okay. C. The speed at which it heats. The speed at which it hits the sea. Apologies. Right, so what I'm going to do is work out the vertical velocity and then combine them like we did in question 1 to work out the resultant. So we know V horizontal is 320 meters per second. So let's work out V vertical, VV, as it were. What we know loads of stuff for this actually. So what's easiest, U plus AT? U is 0, A is 9.81, T is 2.43. Let's do that, 9.81 times 2.43. Answer 23.8 meters per second. Okay, and now I'm going to combine them. So we've got a horizontal velocity of 320. We've got a vertical velocity of 23.8, teeny tiny. Our magnitude will be a squared equals b squared plus c squared. A equals square root of 320 squared plus 23.8 squared. Well, I make that 320.8. Sorry, 320.9 meters per second. So V equals 320.9 meters per second. And again, it's going to have a teeny tiny angle there. So 320.9 meters per second there. So again, let's use tan. Tan minus 1 opposite 23.8 over adjacent 320 equals 23.8 divided by 320 minus 1 of the answer, 4.25. I make that. And this time that is to the horizontal. Lovely. Oh, I might regret doing so many questions. Do you know what? I'm going to pause the video here. You've had enough of watching me do some questions. Have a go at questions 3 and 4. I'll see you on soon.